What if this electric car performed as well as your present car? How about faster computers that are truly user-friendly? What if we could meet the worldwide demand for energy efficiently and safely? Roots opens a new door to the future. We are introducing a breakthrough technology, a superconducting polymer we've trademarked Ultraconductor. This novel conducting polymer is the key to enormous commercial changes in how the world uses electricity. Sales of products incorporating this technology are projected by international industry analysts to ultimately exceed $150 billion annually. The key is here. While it looks like an ordinary piece of copper, laid across its surface is a thin film of specially processed polymer, an ultraconductor. Within this polymer are microscopic structures which can conduct electricity without resistance at room temperatures. Normally, when electricity moves through a wire, some energy is wasted. Resistance causes the wasted energy to convert to heat. Sometimes that's a good thing. It's what toasts our bread in the morning. The heat that made the toast was actually energy that was lost to resistance as current passed through wire in the toaster. But often it's a big problem. From 10 to 20% of the power sent through transmission lines is lost as heat, and it's heat that prevents engineers from designing smaller circuitry for faster computers. Ultraconductors offer virtually no resistance to electricity. This quality, called superconductivity, has already been commercially developed in a number of exotic materials. However, these materials must be cryogenically refrigerated to below -270 degrees Fahrenheit to operate. But our room temperature, highly conductive polymers eliminate the need for industrial refrigeration, a breakthrough of great significance. They open up huge markets for commercial uses, including energy-saving electric power transmission and generation, practical electric cars, faster computers, solid-state cooling, and other possibilities beyond anything we can now imagine. Ultraconductors were discovered by Dr. Leonid Grigorov, formerly senior scientist at the Russian Academy of Sciences and now senior scientist and group leader at Roots. One of the first theoretical physicists to predict room temperature superconductivity, Dr. David Eagles, reviewed the Grigorov discovery and presented his positive conclusions at Brookhaven National Laboratory. Dr. Eagles, formerly senior research associate at the National Research Council at NASA Marshall, has been a consultant to the Roots team. Here Dr. Grigorov discusses how, after his initial surprise and skepticism, techniques for measuring conductivity of the polymers showed unmistakable superconductivity.
We also tried to measure the conductivity using the magnetical methods, and it allowed us to estimate that conductivity is so high that really it is completely comparable with the conductivity of usual low-temperature superconductors.
Dr. Grigorov and his team found that certain plastics ultraconduct not only at room temperatures, but at higher temperatures as well. For now, Roots is proceeding quietly with the commercialization of Dr. Grigorov's work, funded in part by contracts with the United States Air Force. Ultraconductors not only have superconducting applications, conducting electricity 100,000 times better than copper, silver, or gold, but have other breakthrough commercial advantages. Polymers are more flexible, more adaptable, and unlike cryogenic superconductors, keep their conductivity over an enormous usable temperature range, from -450 degrees to more than 300 degrees Fahrenheit. Now, how do we go from laboratory samples to practical products like computers, and what part will Roots play in this new industry? Roots' success is based on a business strategy that aggressively seeks out strategic alliances for manufacturing and licensing its technology. Root's primary focus is ultraconductor commercialization. Conductors are an essential component for an incredible range of industries, and they come in several forms. One is thin film, like the material shown here. Thin film is the basis of microelectronics, and in computers it is used to make integrated circuits and their interconnects.
Thin film will be one of the first technologies to be licensed. The laboratory samples have already been made and tested. They are ready for further development of the technology by manufacturers. Eventually this technology will be utilized for packaging of electronics, in particular for interconnecting computer chips.
Ultraconducting film not only will make computers faster and more user-friendly, but will enhance the battery capabilities of many devices, including electric cars. But to really change how we generate, send, and use electricity in our homes, offices, and factories, industry needs ultraconducting wire. A tiny length of wire has now been made in the Roots laboratory, and high current wire and cable is the next primary focus of development. Ultraconducting wire will dramatically improve the way we meet energy demands worldwide, transform transmission grids, make possible compact and highly efficient appliances and business machinery, even reduce the size of antennas that power cellular phones and other devices. The commercial impact of these changes will be enormous. Annual sales incorporating superconductors are expected to reach $8 to $12 billion by the year 2000, grow to $60 to $90 billion by 2010, and $150 to $200 billion by 2020. Using ultraconducting materials needing no refrigeration, Roots is in a unique position in this emerging industry.